Good morning, friends. Today I'm going to demonstrate the segment routing configuration on the Junos device. This is my topology where this portion of the topology has been already configured with the all required protocols, and the SRGB we are using here is 800K, that is by default SRGB allocated on the Junos, and based on that one we will configure the index value. So I'm going to demonstrate the configuration on the PE1 router. So where I'm going to configure the index value 1 for the IPv4 prefix and 2001 for the IPv6 prefix. So if you can see, this configuration of interface configuration has been already populated, and I'm able to reach the neighbor devices. So let's jump on the required configuration. So I'm going to demonstrate it using IGP as a ISIS. So for that one, first I need to set the ISO format on the loopback 0. Set interface loopback 0 unit 0 family ISO unit 0 family ISO address. Let me configure it this simple way. And I need to configure the ISO family on the all the interfaces. Unit 3 and family, I need to configure that ISO EM1 unit 0 family ISO. Set protocol IOSXR level 1 decibel, I am going for level 2. Set protocol ISIS interface EM0.0. I'm defining as a point to point. Set protocol ISIS interface EM1.0 point to point. So we need to configure the white matrix. So let's say set protocol ISIS for level 2 white matrix only. Set protocol ISIS interface loopback 0.0. So let's configure that as passive. And once we commit this ISIS configuration, so our ISIS agency should be up. Yeah. So our ISIS agency with the P3 and P2 is up. So let's configure the BGP VPNv4 family with the remote PE. set routing option autonomous system. Let's configure it as 100. Set protocol BGP family inet VPN unicast. Set protocol BGP peer AS 100. Set protocol BGP local AS 100. Set protocol BGP group. So I have given the iBGP as a group name. Neighbor. So my remote PE is PE5. Local address is this one. So once we are done with this one, so my BGP VPNv4 should up. Connectivity is fine. So yeah, it is up now. So we can see here bgp.layer3vpn.0. So let's go to the next section, that is the VRF. Set routing instance. Let's say I have given the VRF name is VRF ABC. We need to define the instance type here. So we have multiple instance type like virtual router, VPLS, VRF. So I'm configuring the VRF for this demonstration. Interface which is connected to the CE1, that is EM7.0. Let's set the route distinguisher. Routing instance VRF-ABC route distinguisher. Let's say is 100:65001. Let's configure the route target. So I'm defining this community here. Target colon 100:65001. Set routing instance VRF ABC. Let's configure the eBGP which is connected between P1 and C1. Protocols BGP family inet unicast BGP here AS is 65001 and our local AS is 100. Let's set the neighbor group. Let's call it eBGP neighbor, that is 192.168.1.1. Let's say remove private all, and also we'll configure the AS override as well. So this is the VRF configuration look like. Routing instance VRF ABC, instance type is VRF, interface, then RD and RT value, and this is the eBGP configuration. So once we commit it, then we should see the neighborship up with the CE1. Let's see. Yeah, neighborship is up. but you will not see the remote AC IP address here, learn via BGP, because when PE1 is going to verify the entry for the PE3, it will say that it is next hop is unavailable. So it is going to check the label entry for the PE5 to validate it. So let's see. Show route table BGP layer 3.0. So we don't see any route here, but if we see here, it is showing that one route is hidden. So let's see why. What is that exactly it is showing? So this is the remote CE IP address, that is 22.22.22.22, that belongs to this CE2. So let's see why it is showing hidden. Let's go to the detail. So validation state, it is showing unverified. Next of type is unusable. For that, we need to configure it as LDP, RSVP, or segment routing to reach to the remote P using those labels. So let's configure the segment routing part on the PE3, PE1. So if you're configuring the segment routing on the actual hardware, then you need to configure this command first. Network services, enhance IP. As this is virtual setup, here it's not at all required. Then you need to configure the MPLS address families on this interface. EM0 and EM1. You need to call them under the MPLS. So I have called both the interfaces. And let's set up the basic segment routing, which is default. Set protocol ISIs, source packet routing, node segment, IPv4 index. So I'm giving this index here as a 1 for PE1. Set protocol ISIs, source packet routing, node segment, and this is I'm defining for the IPv4 index, that is 2001. That's it. I'm done with the basic segment routing configuration. After that, it will start in the basic format and you can tweak those remaining configurations. So here SRGB value by default it's 800K. I haven't changed it, I kept it default, but in case if you want, you can change it according to your network requirement. So let's commit the configuration and then let's verify the BGP configuration which we were checking earlier. So now there is no hidden routes, and then the routes become active, indirect, next hop type, and then next hop it's already populated there. So let's try to ping from the C1 to CE2. So let's see if we can get some entries here. Yes. So show route. So we can see that we are learning 22 from the remote P and few IPv6 prefixes as well there. So let's ping the entry from C1 to C2. Okay, looks like we don't have loopback configure on this. Let's configure it quickly. Unit 0 family init. We are done with the loopback configuration on the C1, so now we should be able to ping yes. So let's see the complete data plane. So if we see here the database, so we are learning the LSP from all the devices. So let's say the database from the PE5, and we can see here this is the PE5 database we are looking. This is level 2, and we can see here this is the 800K is the SRGB range, and this is the total range available for that sRGB. Means size range size is 4096. It starts from the 8000 till 804095, and you can see here these are the adjacency-sid assigned it to the neighborship. This is for P3. So one is for P3, one is for IPv4 adjacency-sid, and second is for the IPv6 adjacency-sid. And some flags has been set here. One is for if it is IPv6, this family flag will be set, and this is the local flag for the local, and this V is the for the absolute value. In the case of the prefix-sid, it should set as a 0, because in the prefixes we carry the index value, not the absolute value. And this is the index value for the P5 prefix, that is 5. So it will add this 5 value to the 800K, so it will become 800005 as a label value. And here is the IPv6 index advertised by PE5, so here it will become 800 2005 IPv6 label value to reach to the PE5. Let's see the inet.3 label, inet.3 table. So you can see here to reach the 5, we need to push this 800005 label. So once P1 received any packet from the C1, he is going to push that 800005 label on top of the VPN label, and he will push it that to the P3. He will push it to the P3. Let's see on the P3 what it says. Show route table MPLS dot 0. Let's see for what is the operation it's going to do for 800005 label. So here you can see it is saying the pop. Let's see in the detail. This is the next hop for that one, where it is going to forward that label, that packet after popping that particular label. So here label operation is pop, so it's doing the PHP, it will remove that label and it is going to forward it to the PE5. So let's see what PE5 says. So before that, let's say what a VPN label pushed by the PE1. bgp.lay 3 panel. Let's see detail. So this is the label operation where VPN level is 299.840 and he is going to push the top level, that is 800.0.0.5 to reach to PE5. So let's see what operation it says on the PE5 for this particular level. Sorry, level detail. So the packet receiving with the top level, that is VPN level 299.840, and then it's going to forward it on to this particular interface, that is next of 192.168.2.1 via this EM7 interface, and here it will remove that label and he will forward the plain IP packet towards the CE2. And this is where it will reach to CE2 for this particular interface. So let's see how exactly packet look like on the Wireshark. Let's capture any packet. So if you see here, this is the packet capture between PE1 and P3. So this is the ping packet. You can see the source is 11 11 11 11 and destination 22 22 22 22, and this is the ping packet, ICMP packet. So on top of that ICMP packet, PE1 has pushed the 299.840, that is VPN level, and on top of that one, to reach to P5, P1 has pushed the 800.0.0.5 level on top, and he has pushed that level towards the P3. P3 will do the penultimate hop popping, and then packet will reach with the VPN level on the PE5. PE5 is going to remove this particular level and he's going to forward the plain packet to the CE2. If you need the Junos configuration and the Wireshark output, you can mail me on the below mentioned mail ID. I'll forward it all the complete configuration to you so that you can try the same stuff in your lab. Thank you very much for watching, and I hope you enjoy this one. Thank you. Bye.